Thank you.
Thank you, William. Okay, thank you guys. Nice to be here. Really enjoy this. When I was talking to Alessandro a couple of months ago on a meetup, he talked me about k8s Utrecht, and he said, yeah, we want to have local stuff here. Are you a local? Yeah, damn, I live here. I mean, I can walk home from here, right? I work at the Hogeschool Utrecht here. How local do you want? Okay, he said, that's good. Now, what about diversity? I said, hey, I'm diverse. I mean, I'm twice the average age here, right? So that is my introduction. Still going strong. I'm going to give you the names of the people involved. So first of all, a little bit about me, but I'm handing it over to Bart in a second. So I'm an associate professor, Hogeschool hoofddocent at the Hogeschool Utrecht in, guess what, cybersecurity and cloud. And as another job I run cloud security training. Now I have stickers for both of them, so you can pick them up in a second. And one of the things we did a couple of years ago to improve cybersecurity education for younger people was to start collaborating. And this is where the shout out to Daniel Mijnsma is. And together we started this whole project, which we now know is the JointCyberRange, which I'm going to give you a bit of an overview of in a second. The reason why Bart is here, because Bart was, so it was all built by students mainly. And Bart did 2 terms as a student in that project and was very instrumental in shaping what we will show you here right now. He knows a lot more about Kubernetes and ArgoCD than I do, and that's why he has a nice job in that right now. But I'll hand over to him in a second. So what is this whole idea of a CyberRange? Now, the problem that we're facing as a society is cybersecurity. I don't need to explain that to you guys. You know that already. Our society is becoming more and more dependent on IT, and the threat level for that is also rising. It's getting really out of hand. So there's a strong demand for up-to-date cybersecurity expertise. And it's really hard for educational institutions to keep up with that. And besides, there are a lot of people who are interested in cybersecurity because the nature of cybersecurity is you have to think outside of the box. These people don't often fit in the box of the regular education. And that's why we have a bunch of initiatives to help that. So what we find, and this is not something that I've figured out myself, but this is well known for the past 10 years or so, is that a so-called CyberRange is the best way to do cybersecurity, to learn cybersecurity. And what we have here is just an example of a small and medium enterprise environment, which is nicely firewalled off, and then your students can try and hack that. And once they're in, they can find the flag and so demonstrate that they can access that. And of course, teachers can have a look and watch, provide feedback, and do judgment. And I think this is almost the point where we're handing it over to you, right? Okay, Bart, take it away.
So I'm gonna talk about what we built. Our goal was to build a CyberRange as a service, but this is what we actually achieved. A Jeopardy-style CTF platform, where CTF stands for Capture the Flag. And Jeopardy-style means you have several categories. You have several categories, crypto, web challenges, and points are assigned based on difficulty. The platform is based on an open source project, CTFD, and we built some custom plugins to support automation and more flexibility. And of course, everything is built around Kubernetes. CTFD is hosted on Kubernetes, as well as the database and challenges. We hosted some competitions, Capture the Flag competitions on the platform. And after those competitions have been completed, the learning content can be reused and redistributed, so more people can learn this. There are a couple of challenge types supported in CTFD. So the first one is text-based challenges, the most simple one. You have a description and your title. The title can also be important for your for solving the challenge. An extension on that is file-based challenges. You analyze a PCAP file, for example, in Wireshark. You could look at metadata of an image, or just have a generic set of files in a zip file to perform your challenge. But most interesting are infra-based challenges to work against real infrastructure, for example, a web server or SSH. There are a couple of problems with that. Most CTF platforms, they reuse infrastructure for multiple players. So if one player changes a file, all other players see that. And that might not have the desired effect for the challenge. Another problem is that challenge information is static. So in CTFD, when you create the challenge, you have to provide all the information upfront. But if you want to deploy dynamic challenges, that is not possible. So we fixed that. We built container-based challenges, dynamically deployed challenges on a player request. There are also some alternatives to this to highlight NSGIL and KCTF, both built by Google. They utilize process isolation. For each connection, the process is jailed and it's isolated inside its own jail. And then kubectf, they are inspired by KCTF, and this is from the people from Down Under CTF. They host their CTF competitions regularly. So a container-based challenge consists of a Kubernetes pod. The pod hosts the challenge and the flag, and then a challenge can consist of multiple containers inside a pod. For example, a web server, Nginx with WordPress, or any web server you can think of. But also a Linux container with SSH access. And then your Linux container can be the challenge itself, but you can also use the SSH container as a bastion host, so you can access network services, FTP, or what you can think of. We have a small video. So this displays how the container challenges work. You select your challenge and you start it. The container has now been deployed, and you go to the URL that is provided, and then you can solve your challenge. This is a really basic one, but you can make it as difficult as you please, and also targeting the right audience, of course. Peter?
Okay, I will take over for a second. So we run a couple of live events on this. So this is the last middelbare scholencompetitie that we did. It was, I think, the third event. And what you can see here is the scoreboard over 2 days. So in day 2 we released some more stuff, and then they progressed. This was the Dutch national team that came by on the second day, and then they just solved them all in 10 minutes. But of course, hey, noblesse oblige. So that was a really interesting event, about 100 players. And then the next one, you have the clicker, I think. Yep. And this is the national competition that we did in May, Challenge the Cyber. This was at Radboud Nijmegen. And what you see here on the top is a panorama, so 140 people. We ran it on our infrastructure, on our kit. This is the Utrecht team. They kind of made it to 10th place. This is one of the teachers, Maya. Here another shot of people hard at work, and this is part of the hardware challenge that was also part of the game. So that was this is a real event, and for the coming year they want to work with us again. So we still have some work to do, but that's a call for action that I'll get to later. Now it's back to you, I think, Bart.
We also have an arcade, so you can try out the challenges yourself. Unfortunately, not the container-based challenges due to technical difficulties. So what is our technical model? CTFD is our centerpiece that we make use of. And we employ hard multi-tenancy, so every tenant gets its own CTFD instance and a database. And then a tenant can be a contest like Challenge the Cyber or a school course. We automated the CTFD deployment on Kubernetes, and custom plugins supported us with that. First of which is the initial setup plugin. So Normally, CTFD, when you boot it up for the first time, the initial setup is done through the UI. And well, when you want to do automated deployments, you want to do it through environment variables. And with Kubernetes, we use the config map. Single sign-on is supported through SAML. The educational institutions in the Netherlands, they almost always use the same infrastructure for that, SurfConnect. And we wanted to support that, so schools have had a streamlined experience. And then, of course, the Container Challenges plugin, which enables a new CTF-D challenge type. Challenges can consist of multiple containers, which is way more scalable than VMs. If you have a small medium enterprise infrastructure, which consists of 5 VMs, for example, and you have 100 players, you can think that will be very costly. So containers, it's both more scalable, but also more cost efficient. The container challenge deployment, we make use of Docker Compose files and convert those to Kubernetes manifest. And then you can, and the objective with that is that the challenge developers don't have to know Kubernetes. So they need to be focused on building the security challenge and not building the infrastructure around that. That's our job as platform builders. So Compose with a K, another tool by Google, does the conversion, and then the custom CTFD plugin comes into play. The CTF admin needs to provide the container registry credentials in the UI. Your containers or your images should be private, otherwise the players could look at the repository or the registry and already see the answers. And then, as you saw in the video, the challenge information is provided in the UI. This is an example of how such a container challenge is comprised. At the bottom, you see a Bastion host, which is exposed. You provide a label where you specify the service type. Currently, we use node ports, but we are looking for alternatives. And then the other container is not exposed, but you access that through the Bastion. And then this is how a challenge looks like when you created it in the CTF UI. Now I'm gonna talk a bit about our toolchain and tech stack. So Surf was very kind with providing us with some servers that we can bootstrap our project with and start. To lower the entry barrier for students, we used Rancher for the management of Kubernetes. So it's a bit more tangible with the UI, and Longhorn for its block storage capabilities and S3-based backup. And then, of course, CTFD. We currently maintain a fork, but we're trying to steer away from that by utilizing the plugins infrastructure to its fullest. The usual suspects for observability, so Grafana, Prometheus. Loki for logging, and one nice tool is Doppler. It's a secrets management tool. It has a very generous free tier, especially nice for students. It's way less complex than enterprise and cloud services. For example, Vault. And the JointCyberRange student team also, we even solved some bugs that Doppler had. And for developing the fork, we use dev containers. But when you actually want to do development with Kubernetes, that your app talks to the Kubernetes API, Tilt is especially nice for that, because then your app runs in Kubernetes while developing, and when you make a change, it automatically deploys the new version. We use GitLab for source control management and CI/CD, and ArgoCD for GitOps as an extension to that. We'll talk about those use cases now. So the CTFD fork, the image for that, the container image is built using GitLab pipeline. And we want, of course, some quality checks to enforce some security hygiene. The container challenge images are also built using GitLab. And then we also support challenges as code with CTF CLI. The challenges are described as YAML and then pushed to the CTFD using its API. ArgoCD, we use that for GitOps instead of manual kubectl apply. So the configuration lives in Git, and the actual state is the desired state is reconciled with the actual state. It has a great UI with a resource overview for all your resources. You see the relationships and dependencies between those resources. And it's especially nice for people who are not fully focused on Kubernetes management and operations like Peter. Like, the students build it, but Peter has to manage it day by day. So all the tenant deployments go through Argo, and also the certificates with Cert Manager. Updates and fixes are really easy to do with Argo. You just commit your change, but when you still have when it still doesn't work, rollbacks are also easy to do. On the left, you see all the resources we have in ArgoCD, and on the right, you see the dependencies of a single tenant. We are currently transitioning from our service to managed Kubernetes, Azure Kubernetes. It's a big hassle reduction. A new cluster spin-up is it's minutes instead of half an hour, and it's really easy to do through CLI or infrastructure as code. For storage, currently we're still on Longhorn in AKS. It's not desirable. You want to use cloud provider native storage solutions to have better integration, and Longhorn's also not that great in resource-constrained environments. If your disk gets full or CPU and RAM hits its limit, then Longhorn's not that great in healing itself. We currently chose to go from Nginx ingress controller to the Azure application gateway ingress controller, but that's still debatable if you want to stay on this technical decision. There are a lot of blogs about hosting CTFD and how you do that with Docker and in Kubernetes. When they talk about hosting a real competition, they almost always recommend to use managed databases for its resiliency, security, and backup capabilities. Doppler, we might want to move to Azure Key Vault to have better integration in the cloud provider and also support stuff like secret rotation. We have some challenges with hosting the platform, especially hosting the challenges themselves. So we want to prevent cheating. CTF players currently all have the same flag, so you perform the same challenge, everybody has the same answer, so you can share stuff. That's not desirable. Everybody should have a unique flag, but that means that you have to integrate with CTFD. Something has to generate the flag. It needs to be inputted in the container, and that's a bit of a difficulty. We want to prevent conflicts with tenants. So we need to introduce pod resource limits for CPU, RAM, and disk. Not only for the CTFD tenants itself, but also for the challenges. Somebody can fill up a disk, and then your cluster is not available anymore. Policies. We want to isolate challenges with network policies, either with Cilium or Calico. It should have been done from the start. A nice feature to have would also be to have IP whitelisting. So when a player starts the challenge, the IP of the client IP that requested the challenge, that IP should be the only one to solve the challenge. so you can't ask someone in another location to solve the challenge for you. But we use Docker Compose, but you still have some freedom in that, and we want to limit that using Kyverno policies or maybe Gatekeeper. Kubernetes cluster isolation, we might want to host the challenges in a separate cluster, or if that's too expensive, then utilize vClusters for that. And containers are inherently less secure than VMs because of isolation. And to prevent container escapes attacks to access the host, we want to introduce Kata containers or gvisor. So we learned some stuff from this project, from our endeavors. Kubernetes and ArgoCD for the win. It's Kubernetes for its scalability. But yeah, we have to do some improvements on the challenge isolation. And ArgoCD has a great user experience, especially for Peter. And Longhorn, yeah, like I said, it doesn't work that great in resource-constrained environments. Here you have a QR code to the GitLab repo. So if you want to contribute, there is a lot of stuff to do, but we want to make this a real thing. So thank you.
Thank you, Bart.
Okay, thank you very much for the session.